or clever system of taking the rider and saying, okay, you're now sitting on the seat. Tell me about your groins. Tell me about your whatever. How's that feeling? Is it comfortable, not comfortable? Would you like it softer or harder? And so, for the first time, you're actually able to take empirical data that says, look, this is the actual pressure. And then the rider can say, actually, I don't mind that pressure there, but I would like it a little more supportive here. Or, this is too supportive. It hurts. I need it to be softer. Okay, if you think about your elbow, I mean, you can lean on your elbow pretty hard. Okay, but you don't want to lean on your ear too hard. It's the same sort of concept. So they're able to give feedback through surveys, and then IDV are able to combine that into what they call a smooth comfort map. And that is what we're able then to base the seat on. Inside a seat, we've gone with a sort of like spring structure, or a barrel structure. And each of these barrels then, you can see here you've got shape changing. It will actually adjust that barrel. We've done some FEA analysis on it to predict how it will act. But you effectively have softer and harder springs, and they get distributed according to your pressure load. Again, there's our FEA. What you end up with is a seat that from the outside, a lot of these holes are used just to get the support material out, but from the outside looks like a fairly normal seat. I have here a section of that seat, and I'd like to show you what it does as it behaves. Again, this is just a cross-section cut straight out of it. You can see inside you've got the individual springs, and if I squeeze it, you get different performance depending on where you're at within the seat and how it was pressure mapped. So if you notice in here you've got some thinner wall barrels. Over here they're thicker, and back here they're even thicker. Alright? Suddenly, this sort of layout allows you to map against where the pressure was and what sort of performance you want. It was fully assembled. It was sent to Ducati for testing. The rider on the day felt it just with his hands. You know, he picked it up, went up to his motorcycle, pushed on it, and said, "You gotta be kidding me." Very doubtful that it would be useful for him. He went for a ride. He went for a 20-minute ride, and he went for 40 minutes, and he went for an hour. We had to take it off him at that point because we needed it for our meeting, our project meeting. He asked to have it back. He's testing it more. He really likes the seat. That's the biggest compliment we've received, is that he wants to use it. He wants it to be his seat. Okay? We're pretty excited about that. I think the advantage is we don't need to read through in detail. But it's exciting to suddenly be able for a customer to know that he's got direct input not only from the shape of his body or the way that he's got pressure, but actually how he feels and what he prefers and what he likes. Imagine if you could design a chair for you that was the same concept. You sit in an office all day. What do you like? Do you like a high neck? Do you like... And you just go through and just go down the list and specify everything. It would come out just for you. I imagine this is a little bit like ancient Egypt. In the early dynasties in Egypt, who was embalmed? Only the pharaoh. As time went on, they started to mummify not only the pharaoh, but also his family. And as they got better, and the process was cheaper, and they got all the, they started getting all their different salts and everything from the Dead Sea, along with all their other things. Suddenly, it wasn't just the pharaoh's family, it was his friends and his best friends, and eventually, as you go throughout the history of Egypt, you end up with anyone with a little bit of extra money could be involved, could have a proper mummification. We hope the Custom Fit project is that stepping stone to go from a 2,500-pound pair of customized shoes that only professional athletes can afford to suddenly push it into the middle-class market. If you want a customized product, you can have it. All right? I'm going to skip through this jaw implant because I'd like to focus instead on this knee implant. Anybody here have a knee implant? You don't have to raise your hand if you don't want to say. Okay, In short, you end up replacing the joint with a plate, some high-density polyethylene, and kind of a knuckle on top. The focus of custom fit is actually to customize that tibial base plate. Right now they come in a range of sizes. It doesn't, again, it's the closest fit for your knee. Start with a scan. Take that scan data and I'm going to show you this movie. The brilliance of this, in my opinion, is if you watch this little mouse cursor right here, it doesn't move. It goes to create implant and it doesn't move again. So throughout this entire video, you can watch this mouse cursor stays right there while what's effectively power shake behind the scenes with this quick little user interface. Who is this? I'm going to choose who it is. I import the SQL file and I say go. And you've taken a job and been able to extract a recipe for how to create the ideal knee implant. And you're able to do it then in software without any other user input in a couple of minutes. And you can see he goes through, he measures it, he creates the outside shape, he's matching it. He creates where you've got to cut out for the joint. Now you need a little pin to go down into the bone. Just going to take that off. Okay, it looks good. Okay, here's your little pin. You come in, it's measuring the bone. Where should we put it? There's the best spot. There it is. There's another pin and a third pin. I understand watching this is slightly labored, but I can't tell you the satisfaction that I feel just to watch the entire process happen. And again, that cursor just moved off. There was no user input. There's not a CAD man sitting there dragging things around, adjusting it on the, on the fly. This is a recipe that you can put anybody's knee in and push go. And that is the stepping stone toward reducing the cost and making it actually accessible and more practical as a business model. Again, you've got the finished product here, customized for that knee. The issue of materials comes up again here. In an ideal world, we take cobalt chromium, make the entire plate out of cobalt chromium because it lasts forever. Not really, but it's extremely wear resistant. It's very hard. The trouble is, your bone doesn't like it very well, and it won't adhere very easily. So you need to mix in some titanium, which actually allows the bone ingrowth into that titanium so that it's held fast. So once you have defined the perfect shape, now we go through it. You can see in here you've got red is cobalt chromium, blue is titanium alloy, and with some FEA, you actually go through a series of iterations in order to distribute the cobalt chromium so that it will last the longest time possible. Where most of the wear is, you get the cobalt chromium, and where you want it to attach to the knee, you leave the titanium alloy so you've actually got something that it'll stick to. So we've defined the outer shape, now we've defined all the properties in between, and now we move over to the metal printing process which Hans described earlier, and I'll skip through these quickly, in order to produce a functionally graded part that not only wears well, but can adhere to the bone. There's still a little bit of fine-tuning on the process, as Klaus explained. We've talked about things that Custom Fit's doing now. I'm just going to show you a few slides in closing of what we see as the future, or one of the applications we see as the future, and it's out of research out of South Carolina. In theory, they're the first bioprinting research center for organs. And in brief, part of the research was, okay, let's take a regular heart tube, let's chop it up, see if we can get the cells to grow back together. And over a few